boring as you can possibly be, right? Look at that. There's only 14 and 16 left for chapters. That's cool. Yeah, my wife's telling me I shouldn't be doing this next year because it goes too late. Numerical summaries.
You might want to switch it over the thing.
Boring.
And you got the wrong one.
Oh, you want to see it too?
Yeah.
Oh, maybe.
I have to push several buttons for that to happen. You guys are an awful demanding group. You know what happened today that you missed? Okay, that button's pushed. That button's pushed. That's plugged in. Yeah, that's better. Oh, that worked first time. What happened? Math competition today. 50 different high schools here with their smartest math kids over in Luth Hall. The Shen Academy beat them all. As usual, the girls are smarter than the boys. And we all know that. Okay, so we're going to measure something. We're going to measure the mean, which is also the average. We're going to find the medium, which is something that can't really be measured. It's the guy in the middle. And then we're going to look at the quartiles. Is that a new word? Quartile? All right, we're going to look at the quartile. So there's a first quartile, which is the first 25%, and then there's the medium, which is the guy in the middle, the average, and then there's it's the mean. The mean's the guy in the middle, and then there's the third quartile, the guy at 75% and higher. So there's not a second quartile in the middle because that's the mean. And this is going to provide meaningful information. Yeah, sure. Okay, whatever. Mean or average. Add everything together, divide by the number you have. Your calculator may do that for you automatically. My calculator will. I can put in a data set and it'll give me all those numbers. It gives me the mean, the average, the standard deviation, the variance, the quartiles, the whole thing. Really bad. All right, so average, mean, add my data sets together, divide by how many I've got. So here's, we might have some frequency of data. So I've got 1, 1, and I've got 13 11s. Well, then I'm going to have to go and add a 1, and then I'm going to have to add a 6, and then 2 7s, and 8 6s, and 6 8s, and 10 9s, and 16 10s, and then divide by whatever the total is, 75 in this case. So that's what I would end up doing. So when I find the average, I got to multiply by the number of each of the data points I have. So F is for frequency. And with a little bit of luck, your calculator has a frequency button on it, and that'll make that easy. If not, too bad. Have to do it the hard way. Imagine that you're reading a paper. Well, I'm not going to imagine that too long. But we have 75 players making $76,000. That's a salary of $5 million. Okay, excellent. And then we have philosophy majors. Like, philosophy majors have a job. I mean, give me a break, guys. Living beyond your means. This shows the monthly balance in your checking account, minus, 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 minus. And you only come on top because you have lottery winnings. Yeah, that's going to happen. But mom's going to have to bail him out. Okay, that's a good idea. Percentiles. So you could have the 10th percentile or the 99th percentile. So the National Merit Scholarship students are the 99.99 percentile people. And things like that. So some data point represents the 3.5 position in the data sheet when I locate it. So I might locate something. So I want D5. I want D6. So if we're going to find a percentile, we have to sort the data from smallest to biggest. and then we have to locate the data point we want. So I want the 10th percentile, so that it would be 0.10, 0.1 of the total number, and then that would be my position. Now, if I get a whole number, everything's fine. But if I don't get a whole number, then I have to round the number, and I'm going to round it up. So if I don't get when I do that math and I don't get a whole number, I'm going to round up. So the 5th percentile might be someplace a little bit higher. So I've got scholarships, and I want to know this 20th percentile of the team's GPA, which got $5,000 or more in scholarships. Okay, so I line up GPAs, blah, 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 and are they all lined up? I guess they're lined up. So I sort them. So that's my unsorted list. I sort up the GPAs, and then the top 20 percentile are going to get $5,000. The top 45 percentile, $2,000 in scholarships. I find the spot, the 12th one up would be the 80th percentile, and that position is going to be 12.5, going to be 3.85. So at 13, 3.88 and higher, those guys are going to get $5,000 scholarships. And then I want to locate the 55th percentile, 8.27. I'm going to round that up to 9. You say, well, that's not rounding up to 9. Yes, it is. Rounding up to 9. So I find the 9th position, so the 3.67 all the way up to 3.82 are all going to get $2,000 scholarships, and the ones above 3.67 are going to get $5,000, just like we said they were. The 50th percentile is going to be the mean, the medium. And the medium splits the data in 2 halves, half on top, half on the bottom. It works really good if it's even. If it's odd, then the medium's the guy in the middle there. So I'm going to find the medium, the data set, n plus 1 divided by 2. If I have odd, and n divided by 2 if I have even. After the median, the most important commonly used percentile are the first quartile and the third quartile. So I have 11 homes. Pricing range hit this way. I want to find the median and both quartiles for n being 11. So I go and I drop the zeros and I put myself in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Fine. I find the medium, 0.5, that's 5.5. I'm going to round that up to 6. I'm going to find the first quartile, 2.75. I'm going to round it up to 2. And I'm going to find the third quartile, 11, 8.2. I'm going to round that up to 8. So the 6th data point is going to be my medium. The third data point is going to be my first quartile, and the 9th position in the data is going to be my 75th quartile. And those are different rules than we use in the statistics class, which I just taught last semester. Isn't that lovely? But these rules are much better because they're easier. So the position 6 is 252,000. Position 3, 234,000. Position 9, 276,000. Now we have the first quartile, the third quartile, and the median of the houses. Now, why would we want such a stupid thing? I don't know. Oops. We just remembered that Green Hills is there for 264,000. Now we got to do it all over again. Line up our data sheets all over again. We find that the average, the mean, is the average of D6 and D7. So the median is going to be the average of those two. The first quartile is still going to be at 3. The third quartile is still going to be at 9. So the only thing that changed was the median. So that's perfectly okay too, I think. We now find the medium and the quartile of this statistics form. So somehow we're going to graph this pretty soon. I just feel it in my bones. Okay, so we have 75, which is an odd number. We go and we get everybody together and find that, what do we find? I don't know what that is. Anyway, we figure out which ones we're supposed to find. So the 19th data set is the first quartile, 1/4 of the 75 total. We round it up. We find that that the 8s is sitting there, and that's where the mean's going to be the first quartile, blah 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 blah, third quartile. All right, enough of that. SAT score is much better, and so we're going to do the same thing with the SAT scores, except there's too many of them, so it'll be a bummer. Okay, boom boom boom. Here we go. We're going to do box plots. Okay, when was the last time you used box and plot in the same juxtaposition next to each other?
Algebra 1.
Yeah, Algebra 1, really? So in order to do a box plot, we're going to need the first quartile, the third quartile, and the median, and then we extend our box with whiskers. So there we go. And so we have some maximum, some minimum, and we have whiskers coming off our box, and the first and third quartile, and the medium sitting there. And if we're lucky, we color it in blue if we brought crayons with us. All right, so this is the Stat 101 data set. First quartile is at 9, third quartile was at 12. I don't remember that, but you probably do. Somebody scored a 1 and somebody else scored a 24. And that's going to be meaningful to us. Yes. I doubt it. This figure shows a variation of the same box plot, but the two outliers are marked differently. Okay, so the guy that's sitting at 24 and 1, because he's so much away from the 6 and 16, the next smallest guy, we use them as outliers and segregate them from the whole group. And we don't allow this 24 person in the class anymore. We just give them an A and have them go away. So here we have engineering salaries and agricultural salaries from some fictional school. Which is probably okay. That's why you guys are not agricultural majors, right? And we superimpose the box plots of the same scale. I thought they were before. And we look at medium salaries, blah, blah, blah. Isn't that nice? Oh, all done with that. Let's see if we can solve a problem. See if we can find what page we're on.
549.
549. Now I failed to mark how far we got last time.
33 is what we're on.
Okay, so we're gonna do 33 first. Yeah, now I got it marked. I remember we got to 33 and there's a bunch of words we didn't understand. Chapter 14, number 33. Consider the data set. Okay, so the first thing we're going to do is take the data set and put it in order. Minus 6, minus 5, minus 3,
2, 3, 4, 7,
2, 3, 4, 7, 8, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So n is equal to 9. 1, 2, 3, 4, 1, 2, 3, 4. So my medium guy is right there, sitting at 3 in the middle. Okay, now the first quartile is going to be 25% of 9. Luckily, I have my calculator.
.25.
2.25, which we're going to round up to 3. And the third quartile is going to be at 75% of 9. 6.75, which we're going to round up to 7. That being the case, the first quartile is third guy in, 1, 2, 3, minus 3. And the third quartile is the seventh guy in, 1, 2, 3, 4, 5, 6, 7 for a 7. Okay. Consider a different data set obtained by adding one more data point. Find the first and third quartiles. Okay, what did they add? They added in a 2. Alright, so they added in a 2. So we'll come and grab our data set, copy, and paste. And we're going to add in a 2. Okay, so now it didn't ask for a medium, right? But now the medium is between 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the medium is going to be at 2.5, but it didn't ask for it. Okay, so we're not going to calculate that. The location of the first quartile is going to be 1/4 of, well, there are 12 of them. 10. 1/4 of 10, also known as 2.5, which I'm going to round up to 3. The third quartile is at 75% of 10, also known as 7.5. I'm going to round up to 8. Okay, so Q1 is minus 3, and Q3 is 1, 2, 3, 4, 5, 6, 7, 8 is 7. So even though I added the data point, neither the first or third quartile changed. The only thing that changed was the medium, which they didn't ask me to calculate. Number 39. Number 39. I've got an N. 1494531. College-bound seniors took the SAT exam. Assume that the test scores are sorted from the lowest to the highest, and the data sort determine the median position. Okay, so the median position is going to be 1/2 of 1494531, and then we're going to round that up. And then they determine the first quartile position, 1/4, 1494531, and the third quartile, 3/4, 1494531. Now, if I don't fat finger a key, I should be okay. So 747,265.5. Three 73632.75 1120,898.25. All right. So the medium is going to be at position, the location of the medium, 747265666. Because I round up. The location of the first quartile, 373633. The location of the third quartile, 1120899. Okay, that was 3941. For the data set, find the number summary. 5-number summary. So we want to find the average, we want to find the mean, we want to find the first quartile, we want to find the second quartile. What's the 5th number? Exercise 23B. Oh, 5-number summary. Okay. So we want to find the smallest value of the data. So we need the minimum, third quartile, medium, third quadrant, largest number. Okay. So we don't need the average. That's too hard to calculate. So we're going to want the minimum, the maximum. Okay, so that's what I'm doing. 41 is the problem I'm doing. All right, so put the data set in order. -6, -5, -3, 2, 3, 4, 7, 8, 8. Okay, so I'll go with the minimum is -6, the maximum of 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. So the medium is 3. The first quartile we decided was -3, and the third quartile is 7. But we already did that. We determine, find that, plot it. All right, I'm going to plot it. Boom, 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 boom. Okay, so there's my plot. -6, -3, 3, 7, 8. 41, 45. Approximate. Approximate what is the median salary of the agricultural majors, assuming, yeah, we're looking at the guy up above. Okay, that looks like 43,500. What do you think?
Good to me.
Perfect. Approximate what is the median salary of the engineering majors. We'll go with 50,000. Now, because we're approximating it, anything goes. C. Explain how you can tell that the median salary for the engineers is more than the third quartile summary of the agricultural majors. Okay, well, C. Because that is smaller than that. Now, is that good?
I just draw that and call it a day. Or...
Yeah, I would.
Okay.
What do you think? Is that clear enough?
Sounds good to me.
That's plenty clear? Okay.
Like that. Okay.
All right. All right, that was good. 45. We're now looking for 49. And we can't do 49 yet because we haven't done the other section. All right. So back to more transparencies. I certainly hope that chapter 16 is more difficult than this, but unfortunately it probably isn't. Why is that? Why can't we do difficult math anyway? It must be the instructional pool. What do you think? Yeah, if we had better instructors, they could do better math. That's it. I got it now. Measures of spread. Okay, so we have the awesome range, which is maximum minus the minimum. And then, do we have anything else? So if I go from 24 to 1, that's a range of 23. I go 16 to 6, it's a range of 10. Then we have the interquartile range. Isn't that cool? When did you last in polite conversation say interquartile range? No. You're there paying your phone bill, and you know the interquartile range of the phone bill seems to be a little large today. You know, I don't think so. That'd be Q3 minus Q1. So if I wanted the interquartile range, I'd have to calculate Q3 and Q1 to figure out what it is. Isn't that lovely? I can't. Well, anyway, I don't remember ever doing that except in this class in my entire 63 years of life. Then we have the 5-number summary of the minimum, the maximum, the mean, the first quartile, and the third quartile. And with that, we can get the interquartile range. All right, now we get to something worthwhile. Standard deviation. So this is a deviation from the mean. Now, in order to have its standard deviation, we have to calculate the mean first. And that's just the average. Okay, and so we're gonna see how far away each of the data points is from that average. That's the whole point. All right, standard deviation measure from the mean are themselves a data set, blah blah blah, and we also have a variance. So we have the variance, which is the difference between a value and the mean, and if we take the square root of the variance, then we get the standard deviation as long as we divide it by the right thing. Okay. So I'm going to find the variance x minus a, and then I'm going to square each of these, and I'm going to call that the squared deviations. I am. Okay. No, I'm not. I'm just going to put it in my calculator and push the standard deviation button. It's going to tell me what it is. Then I'm going to find the average of the squared deviations. I'm going to call this the variance. And then I'm going to take the square root of the variance, and I'm going to get the standard deviation, sigma. Isn't that lovely? Do you think we can do that quickly? Let's see. So we'll come up with some data set. So I got 1, 2, 3, 4, 5. Okay. So what's the average? What's the mean? 3. All right, so I'm going to find the variance. Variance. All right, so I got a variance of away from the mean. I got a variance of 2, 1, 2. 2, 1, 2, 2, 1, 1, 2. Okay. Then I'm gonna square the variance. What am I gonna call it? I'm gonna call it the squared 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 something. What am I calling it? Calling it the squared deviation. Oh yeah. Yeah, a bunch of deviants. So I'm going to square each of these and get 4, 1, 1, 4. And then I'm going to sum the squared deviation 4, 8, 9, 10, 10. And then I'm going to divide it by, I'm going to find the average of that. So I'm going to divide it by 5, and I'm going to get 2. And I'm going to call this the variance, V. And then I'm going to go and take the square root of the variance, V, and I'm going to call that my standard deviation, sigma, and the square root of 2 is 1.414. Or I could just leave it square root of 2 for all I care. You know, that'd be perfectly okay too. So I can do it, right? I can follow that rule and I can do it, or I can just put the data set in my calculator and have my calculator do it for me. That's okay too. I like that idea much better. But for tonight, we should be able to do that because we just looked at it. So we're going to find the mean. We're going to find the deviation from the mean. We're going to square each of the variations. We're going to go and find the average of those square variations, and then we're going to go and take the square root and call that our standard deviation. All right. Over the course of the semester, Angela turns in all her homework. I find that hard to believe. Her grade on the 10 assignments are that. Why aren't they all hundreds? Our goal is to calculate the standard deviation in the old-fashioned way. Okay, so we find the average. We find that to be 90. Okay, so we find that my variance is minus 5, minus 4, minus 3, 2, 1, up to 5. We square those and we get these numbers. We add those numbers together and divide by the total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we get an 11. We then take the square root of 11 and we get that her standard deviation is 3.3. Now, in the next chapter, we'll use the standard deviation to tell how many data points are plus or minus 1 standard deviation. But this is chapter 14, so we don't have to worry about that. Interpreting the standard deviation. All right. The consistency of data. Okay, excellent. Interpreting the standard. On the other hand, there's a lot of inconsistency in the data. Yeah, that could be too. Summary of standard deviation. The standard deviation is the most important and frequently used measurement. When was the last time you got a grade and a standard deviation with the grade? Never, right? So this is so important they never even told you what it was, right? And I should do that. I should when I pass out grades, you have an A and your standard deviation is 5.2. No. Give me a break. No one's gonna. What's so important about it? When was the last time your employer handed you a paycheck with the standard deviation of your pay as part of the calculation? Really important. Thank you, author, for making something important. Summary of standard deviation. For example, blah, 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 salaries, blah, blah, blah. But it measures the spread. So if the standard deviation is big, that means my curve is going to be flat. If my standard deviation is very small, my curve is going to be peaked in the middle around that mean. A standard deviation of 0 means all the data sets are the same, and I just have a straight line going up. Oh, done with that. So are we on our goal so far? Forget what our goal was, but get out of here before 9:30 or something. I don't know. Okay. Yeah, some goal like that. I forget what it was. Okay, so we're on problem 49. Yeah, 49. All right. Number 49. A realty company sold 341 homes last year. Minimum first quartile, medium third quartile, maximum. Find the interquartile. You gotta be kidding me. Interquartile. I can't even spell interquartile range. Okay, so that's Q3 minus Q2. Can I do it in my head? 41,000. B. How many homes sold for a price between 115 and 156? Well, that'd be 50% of them because they picked the first quartile and the second quartile. So 50% of the total, 341. Oh, that looks like a bummer. Looks like a trick question, right? If you don't believe that you have enough information to give an exact answer, then give an answer that isn't exact. Okay, well, I don't believe I have an exact answer here because it's a stupid problem, isn't it? with an odd number, 0.5. Okay, so I would, this is 170.5. It is? Yeah, it is. So at least 170, at most. Good thing they told me to do that, otherwise we would have sat here changing thumbs or something, trying to figure out what's going on. Okay, so that's 49, 55. Oh, well, this is going to be simple, I can tell. 55. A. Find the standard deviation of 5555. Well, they just told us that if they're all the same, it's 0. So we just write that down. B. Find the standard deviation of 0, 5, 5, 10. Okay, so the average is 5. The deviation is 5005. The square of the deviation is 250025. The average of the deviations, 50 divided by 4, is, I don't know what that is, 12.25? 12.2, right? 12.25. And the standard deviation would be the square root of 12.25, which I can't do in my head. Bummer. It would seem like I should be able to do that in my head, right? I mean, really, 3.5?
It's 12.5.
Oh, it's not 3.25?
5.
5? Which, of course, makes this answer wrong over here. Now I got to do it all over again. The square root of 12.5. Boom. 3.53553335. I think we'll just stay with 3.52 digits. Would that be okay? Oh, way to go. We would stay with 3.5 if the instructor could write a 5. All right, perfect. All right, C is next. C is next. So our deviations are our medium, our average. Our average is 10. Our deviations are 10, 0, 0, 10. Our deviations squared are 100, 0, 0, 100. The average of the deviation squared is 200 divided by 4 is 50. And the standard deviation is the square root of 50, which is 5, the square root of 2. Except that this is not an algebra class, so that would not be an appropriate answer, right? That's perfectly okay, but clearly we want something that, other than that, 50. My calculator's in exact mode. It gave 5 the square root of 2. Thank you very much, calculator. Stupid thing anyway. 7.07, we'll call it 7.1. Okay, well, at least we don't have to do 57 when we have bigger data sets. 63. 63, oh my goodness. Find the mode. Did we discuss mode yet? Of the data shown. If there's no mode, your answer should indicate so. All right, excellent. So the real issue is, did we ever talk about mode? And it would have had to have been Monday if we did, and that's too far away. So mode is the most. So if I have 1, 2, 3, 3, 3, 4, 5, 6, 7, 1,090,754. That's my data set. Then the mode is 3 because I have 3 of them. Okay. So I look at this and the mode is clearly the Caucasians. So number 63, the Caucasians. Excellent. Oh, 73. Almost time for the quiz. You guys ready for the quiz? Number 73. I don't have it electronically either, so that'd be a little bummer. In the height of the column over the class interval, if the height of the column over the class interval 20 to 30 is 1 unit, and the column represents 25% of the population, then seems to me like they left something out of the question. We'll try. We'll see. So we have some chart, and we have some interval on the chart, which is 20 to 30. And that's 25% of the population. So I get a 4-0 for drawing the chart. A, how high should the column over the interval 30 to 35 be if 50% of the population falls into that class interval? Okay, so A. So this is 10, and 10 times point, so 10 times 0.25 is 2.5. Okay. And I've got an interval that's 5. That's going to be 50%. 2.5. That doesn't make any sense. Anyway. All right. You cancel that thought. That's a stupid thought. All right. We'll drop this down a little bit so I have some room. Okay, so if this is 1, then my area here is 10, right? And if I go out to 35 and I'm going to have 50%, then the area of this guy's got to be 20. Twice as much, right? So if the area of that guy is 20 and I go across this way 5, then I have to have a height of 4. So I'll put a 4 there. How high should the column over the interval 35 to 45 be if 10% of the population? Okay, so we have another interval, and it's 35 to 45, and we want 10% of the population in that interval. Okay, so that's going to be so if 50% gives us 20 for an area, then 10%, if 50% gives us a 20 area, then 10% is going to give us a 5 area, right? And if I got 10 there, that means I'm going to have this guy be at 1/2. So B, the height would be 1/2. How high should the column be over an area over the interval 45 to 60? All right, so now I ran out of room. 45 to 60, and I want 15%. All right, so if I want 15%, then my area has to be 7.5. Has to be my area. And I have, what do I have there? I have 15. So 7.5 divided by 15 looks like 1/4. That looks like 1/2. Yeah, it looks like 1/2. All right. C, 1/2. Okay, was that weird enough? Did that even cover what's in the book?
No.
Didn't look like it to me. Anyway, well, this is running anyway, the running problem. So, one more problem, if we can get that high. 89. Really? 89? Okay, I found 89. Number 89. Find the standard deviation of the data set, blah, blah, blah. Okay, so I got 30, I got that guy, and I got that guy, and I got this guy, and I got that guy. And I don't know anything about the guys in between, right? Except that these guys all went up by 1. And therefore, we can assume that all the guys in the middle went up by 1. Is that what they're trying to tell me? Exercise 78B, 79B, and 88. Where's 88? Oh, look at that formula there. That's an interesting formula. And 79B. Okay. All right, so back to looking at this guy. How many data points do you think we have? How about 98? Do you think we have 98 data points?
Yep.
Okay, so N is 98. And that makes it even, right? Okay, so the middle is going to be 143 plus 315 divided by 2, right? 143 plus 315 divided by 2. 364. Maybe I have an odd number. 364. No, there's 99 data points. Because at 414, that would be 100. And when I count 415, that'd be 101. So I have 99 data points. All right. And the mean is 364. Now, on problem number 88, it says if I have 1 squared plus 2 squared plus 3 squared plus blah, 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 up to n squared, that's going to be n plus 1, 2n plus 1 divided by 6. Okay, now, what's half of 99? 99 divided by 2 is going to be 59. Okay, so I've got a 0 squared guy here, right? Because the 99th guy, the guy in the middle, is going to be 0, the deviation. But I'm going to have 49 of them. So I'm going to go 1 squared plus 2 squared plus blah, 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 up to 49 squared. And I have 2 of them because I have I got it on this side and that side. Okay, so I'm going to go 2 times 49 times 50 times 249 plus 1. 99 divided by 6. Okay, and that's going to be, and then I'm going to take that number and divide it by 99 to get the average, and then I'm going to take the square root of it to get the standard deviation. Certainly would not want to do this problem without the hint. But other than that, I'm okay. So all I got to do is put it in my calculator. Two times 49 times 50 times 99 divided by 6. I don't believe it. I don't believe it. Oh, maybe I do believe it. Standard deviation, 284. Oh, I don't believe that. I didn't divide by 99. Darn. I'll do it again. Divided by the square root of 99. Boom. 28.6. Much better. I believe that. 28.6 standard deviation. As a standard deviation means that 68% of all the data points are plus or minus 1 standard deviation, and that would make sense that that would be the number. Okay, so that was all right. No, Scott says it's hosed. What? What? No, you're just complaining about doing it, or in general?
I say we should just
Did I-
start with-
Did I skip enough steps? I think Scott's saying he doesn't want me to do B. All right, let's try B. All right, we're gonna set a time limit on B. If I don't have B done by quarter after the hour, we'll go directly to the quiz. How's that?
Why don't you give us our quiz and we'll start working on it while you try and figure out B.
Oh, there's an idea. Why didn't I have? How come the rest of the class can't have really good ideas like that? I mean, that was a great idea.